Yes, Tushar.
Sir, if the list is sorted, then we can use binary search
Okay,
to
so
check
it is for what? Opcode table or symbol table?
symbol table to check if the symbol is defined again, redeclared.
Okay, if it is redeclared, then correct. But what like this is not a static data structure. Am I right?
Yes, sir.
This should be dynamic. Now, if it is going to be dynamic, then it is not like with the way we handle variables, because you are going to refer those symbols in between the code. Like if it is a label, see if it is a variable, then it's okay. But if it is a label, then we don't know what address it is going to get. So you cannot apply sorting there, because again, if you already say, for example, took a label called LP from the code, fine, and then you saw that you added that entry into symbol table. Now that symbol, that definition is undefined. I don't have any address there. Then uh, it would be great if I have this kind of label, which is referred earlier but defined later. So this is forward reference. If it is backward reference, then already have a label LP colon. I already have address of that LP. Now wherever LP is referred, I have to make changes in that LP. And that's what would be problem if you try to sort them at runtime, because you cannot change again and again the values. Am I right?
Yes, sir.
Because if you recall what I shared in my earlier meeting, probably the screenshot, or maybe when I showed you how exactly the translation process would be, at that time you might have seen that I used to write symbol entry, symbol table number one, or entry number one kind of, if you recall correctly, correct?
Yes, sir.
Yeah. Bashir, what you gave thought on?
Yes, sir.
Have you given thought on this? What we discussed yesterday? Hmm? Bashir.
Yes, sir.
Okay. Have
Sir,
you? Yeah. Go on.
sir, I cannot attend the class.
Okay. Okay.
Yeah.
Yeah. Sakshi. Sakshi. I'm I'm not able to listen. What exactly you are saying? Sakshi. Okay. I'm noting down your name. Like because you aren't responded. Yes. Roshan. You can talk. You can tell me what exactly you gave a thought on. Roshan, can you hear me?
Yes, sir.
Yeah. Go on.
I have searched for the particular uh,
Hmm?
labels,
Hmm?
like
Sorry. Sorry.
which all labels are there in the
So how will
program.
you manage them? How will you manage them? Arya? Arya, are you there? Balirao? Prasad, can you hear me?
Yes, sir.
Yeah, so you are supposed to talk. Let me know your opinion about this structure. How will you manage it? Go on.
Sir, I have done it using list.
Okay. So like what exactly you did there? Please elaborate.
First, I split it using the instruction format.
Hmm.
Then check addresses and where it's belong to which section, whether it's in text or data section.
Hmm.
Symbol is defined or undefined.
Hmm. Okay.
And
And how you organize that list in what sense? What is the structure of that list?
array means we use list in Python. So
Okay. You used list in Python. Okay.
yes, sir. It's same like array in C.
Okay, but like how many columns one entry will have in that list? Hmm?
Sir, one is for ID, then name, then value, then symbol defined or undefined, then section which it's belongs to, and address.
And then how you search into that? How will you
Sir,
search into that?
I haven't done that part yet,
That part.
but
Okay.
we can use binary search there if it is sorted manner,
Okay.
or we
Pratik?
can use linear search, but time complexity management will not done so.
Get hampered. Yeah.
Yeah.
Okay. Okay. Pratik? Pratik? Are you there? Pratik, Sakshi, and Arya. Roshan Gadge?
I didn't do it, sir.
Sorry?
I didn't do it, sir.
Why? What was the reason? Roshan? He left. Okay, so let me just then really discuss mainly like what possible approaches could be. Okay, so it would be a bit theoretical today as well. Okay, but let us see like if I can share the screen whenever required. Fine. Now, whenever we are talking about these dynamic data structures, yeah, problem would be for your static data structures too. But when we are dealing with these dynamic data structures, ultimately organizing them and defining the search method for each of those would be one of the difficult tasks that can be seen rather when we are trying to implement them. So if I talk specifically about symbol table, let me put some say probably approaches which can be used by you. The first approach is like what he before a while was suggesting, a linear array in the list form. OK. Now what would be problem if I use linear array? So in the sense when I say linear array, I would be storing symbols as first consecutive entries of an array. And whenever new symbol is inserted, I will try to add it at entry number n+1. Correct. Now I will have limitation with respect to this array. The limitation is I need to always define how many members possibly can be there as a part of array. And this is what one can say as a limitation for it. Second aspect would be as what the way Tushar suggested, a sorted array with binary search. Correct. I hope Tushar, I think you suggested same thing, na?
Yes, sir.
OK. Now, OK, one thing that I missed, like what would be advantage of using that array? It is very easy to implement, correct? Simple array. If I talk about the list, it is very simple operation. And insertion would be fast because you know what was the last element that you inserted. You can directly insert that n+1 as an n+1 entry. Insertion would be fast. Most of the operations would be simple. You have not to do anything, something called as major thing. But problem would be is it would be very slow in searching aspect whenever I have value of n to be very large. Now if array size is 10, then it's OK. I can very easily search in an array of 10. But when I say array size is 1000, then ultimately finding out the last location where exactly I have to insert the record would be difficult. Even searching values would be one of the difficult tasks. And that is the reason why maybe a sorted array with binary search would be efficient in comparison to a plain array. It would be same linear array, but it is sorted one. Now, what would be advantage? Again, like as an array is there, fast insertion and fast search because binary search is there. As the table is already sorted, it would be very easy for us to find out addresses, find out the objects. But again, advantage would be what? Every time whenever you are inserting a new element, you have to sort. Every time you have to sort it. One approach is after every insertion sort, or otherwise collect complete data, then sort. But when you collect complete data of symbols and variables, again you may have to revisit the code one more time to get the addresses. Now, as sorting is taking time, this is the additional parameter added because sorting is added there by you. So see, like one cannot directly think of using sorted array even. It would be good if I have an opcode table as a sorted array, because it would be easy for me to search because it is a static table. But when it is dynamic table, sorting would be difficult. Now two options, either you sort at the time of insertion or you sort after all symbols are collected. Anyway, time would be varying. Additional task, additional work is there to be carried out. Then, OK, you may think of a linked list. Linked list is kind of an array only, correct? It is array ultimately. Only thing is it may not be consecutive at consecutive locations, that who knows? the free list elements or addresses may be captured in a sequential order too. We may or may not be sure about this at the front. So whenever we are talking about this sorted array, difference with respect to time spent would be much more depending upon how many elements are, what is the value of n, which is size of that array. So when I said linked list, even linked list would be acting in the similar fashion, though maybe the elements are created up the front by without without talking about static one, create a dynamically allocated memory area. But it would be acting in a similar fashion. And I like if I think of sorting that linked list too, it would be similar. Why not think array itself is a linked list? Though we are controlling it without a pointer. So if at all I have to improve that linked list operation, then let me think of what Tushar was suggesting in the previous session. Bucketed linked list. Have buckets. Create 26 entries of array. A, B, C, D up to Z. Now, whenever you are getting any element with A, would be added in the linked list dedicated for the first entry for A. Every element starting with A would be added as in a linked list. So you would be actually seeing 26 different linked lists with assumption that I am talking about A to Z characters. Now, if you permit numbers to be as a starting element, then your number of options, buckets would be changing now. Now, even suppose like we have a habit generally, if I am giving variable names, then my variable names mostly would be starting, say, for example, with I only. Most of the variable names would be with I only. So if I have hundreds of variables with I, then see the linked list for I. A, B, C, D, E, F, G, H, and then J, K, L, M. All these are maybe having very small number of elements in a bucket, but I is having very huge. Then searching time would be again increasing. So definitely it would be very fast. But in this case, while you are talking about creating that bucket, now what exactly I am thinking in terms of bucket, let me show you. Okay. Now think of this that it is A, it is B, it is C, D, E, F, G. Now you can give a thought on this, even like you are having theory of computation course in this semester. And you would be learning something called as Turing machine, definitely at some point of time. Suppose you have to prepare a Turing machine for sorting an array with these characters. When suppose number of characters are known to you, A, B, C, D up to G, say for example. Let me assume that these are my 26 elements, though I don't have 26 right now. Correct? Now, if I have variable with A, I will add here. Suppose these are my variables. Now, similarly, if I go with this, suppose I am adding similar kind of names. Assume that these are either labels or variables. Same thing would be for C. Now each node here is representing one entry of that symbol table. The way that was really put forward by probably Bhale Rao or Tushar, what elements would be there in your symbol table entry. So assume that each element here, like for example, Apple, absolute, appear, ask, address, though they seem to be different names, but it is actually having a very big list in between as a node data. Now, if you think of organizing it like this, it would be very easy because we know where exactly I have to put that data, put that element, because I have sorted. I do have buckets created with A to Z. And if I see that my programmer doesn't use like by habit, if he makes use of or she makes use of only starting variables, starting name through A to G only, then my table size would be flexible. I may not be using any variable name starting with I, probably. Example, sample case. So you can even search what are the variables that you declare tilde in a programming language like C or even Python. You will identify that you have a habit of providing names in a same manner. Right? In the same manner. No, advantage point of view, it is very easy because you can know now where exactly I have to search. Correct? Because if it is to be added, then if name starts with C, I will go to C and I will add that element there. If it starts with G, I know where exactly it is to be added. Correct. But what would be disadvantage? Now problem is every time, every element will have a pointer. This also will have pointer to this. So pointer should be to this and to this next. If I create this as an array, say for example 26 entries, each array element will contain address of head node. So again pointers. Each node would be having address of next node. Each node would be having address of next node. So there are too many pointers. And as each step involves use of pointer, it is going to be very slow. In comparison to using arrays, though it looks good in some form. But we cannot assure that would be getting exactly what we are supposed to put forward. Now question would be like here it is good, like we identified that our variable numbers are starting with A to Z. What if I use a symbol or a character other than alphabet characters? The problem for me would be now, can I use this data structure? Because we saw a variable name can start with underscore. Then what? If my variable name starts with double underscore, then what? If I have to you permit this kind of access, then definitely I have to give a thought. If at all I do permit it, yes, okay. Let me find out how. How will you permit this underscore parameter? Why I am saying so? Let me show you. Sorry, dash G dash. When I write this breakpoint main, okay, even before a while, Let me show you this. You can see that how many variable names are starting with underscore. Now this starts with double underscore. This starts with double underscore. Correct? Can you see this? Now, if it is starting with double underscore, how do I manage this? Now, how exactly it might have managed? And if we see, this is a symbol table for that system, for that code that was added by us. Symtab entries, you can see. And it is not sorted the way that we are expecting. And we are even not sure whether it is a bucketed one, because I can see CRT, C here, then C here. Right? C here. They are appearing at a different point or different place. I'm not getting them in the same sense where exactly I should have considered them. Even you can see deregister my data start toward the bottom. Correct? So definitely there would be challenges even if I am thinking of making use of these underscores. How exactly I'm going to do this? So what was the next option, third option that we saw? Bucketed linked list. Fine, but this can be good approach provided you are using C or C++. Next would be binary search tree, BST. I hope you must have worked with binary search tree. Am I right? Have you heard about this in data structures?
Yes, sir.
Okay, what is BST? So if you
Lesser values on left side.
okay, what? Can you repeat, please?
Values which are less than root are on left and
Okay.
greater are on right.
So you are having some sorting mechanism provided. Correct. Now, if you recall, when you learned databases, you were told that databases mainly make use of B plus trees. Right? What is that B plus tree? Is it BST only? Have you heard about B plus tree? Yes, please. Have you heard about B plus trees in databases? Balerao?
Yes, sir. It's insertion, deletion, and searching technique provided in databases.
Databases, correct. So it is kind of BST only. Now this BST is not only useful for symbol table, but can say it is said to be used for almost every assembler. Suggested one, because this is said to be the one of the most efficient. It is said to be one of the most efficient. That means what there you have to define a strategy the way that he stated. Like if we talk about numbers, then if it is less, then we go to the left, and if it is higher or greater, then we go to right. Correct. So ultimately here you are going to see the elements by comparing value of the node to be inserted with the root in terms of lexicon values. Lexicon in the sense, because you are going to have variable names, identifiers here. And every time recursively you have to execute that pattern. So if suppose my first variable names comes as zebra. So suppose I inserted at first point, next element comes apple. Now what should I do? Whether should I arrange it with zebra? Zebra is said to be last. So apple I will insert toward left. Correct. Now if I have new variable occurring as pink. Now what should I do? Should I include pink in the right side, or pink always would be left side? So if my root is zebra, then ultimately I cannot insert anything towards right side, because Z, unless new variable starts with Z, I have to insert everything towards left. So this reorganization of tree the B tree or binary search tree needs to be done again and again at the time of insertion. That care should be taken by comparing the root. It is very easy to say left and right, but are you going to keep your root as intact? Because if you are going to keep root as intact, and if your root name is zebra as a variable name, until unless any variable starts with Z occurs, nothing would be inserted there towards right side. Am I right? Are you with me?
Yes.
Yes.
Now how do, so you may agree that like this BST, whenever new insertion is done, needs to be reorganized again and again. Correct? So now it would be one of the most efficient operation, no matter how many elements are there, because average number of steps would be less in comparison to other mechanisms. But the problem is it is going to be very complex in comparison to what we saw an array based one. Comparison definitely would be required at some point of time, which one is better and which one is efficient. So either you are talking about efficiency or you are talking about space. How much size it is taking, how much easy it would be for searching, and so on. So as a parameter perspective, like if I am suggested to choose between, say for example, if I talk about only these four, then I may go with either of them, like either a BST or bucketed linked list. But then someone may say, can I get one more option? Probably yes. Why not think of as a hash table? Create a hash function, define an hash function. Have it as a closed hash table as an array perspective. Define some function which would be useful to organize these elements. So either a closed hash function or probably open hash table or open hash function. So now what can we combine together a hash along with bucketed linked list? Instead of going with the mechanism with respect to the mechanism that was suggested, like having A to Z as 26 elements and then organizing. But we saw habit of programmer can lead it to one element only, one bucket is getting filled. The rest of them are not used at all. Correct. So this hashing definitely would be one most important parameter probably, which will permit you to combine earlier choices. Definitely array would not be suggested one. Even if it is a sorted one, I will try to avoid it. I will choose in between these three. What are the last three mechanisms we talked about? Starting with bucketed linked list, correct? Then a binary search tree and probably hash table. So even somebody can come up with another model, which might be combination of one or two or maybe more. But when you go with these implementations, starting from arrays till hash table, complexity of implementation is going to be very difficult to handle for. Because it is good to say, like if I am saying use an hash table, but problem would be you have to start from scratch. How exactly I'm going to define my hash table? How it should be? So Sakshi wrote something like we can use struct keyword to bind all the columns. Ultimately, you are using an array. Correct? Ultimately, you are using array structure, array of structures. So think of, suppose you get, if you are asked to translate this, translate, I mean to say sort it, too many problems can occur in that case. Because complexity would be getting hampered. So then what would be better choices for me? What would be the best technique that you think would be suitable? Because for implementation perspective, the way I understood from one of you saying that I will use simple array. But if it is going to take too much time, then nothing you can advocate to justify your choice of data structure. Until and unless you try and decide which one would be better, because even it is very easy for me to suggest why not use hashing or why not use hash table. But implementation is to be done by you. So you will be required to give a thought on which data structure seems to be efficient for me so that I can target the whole process. So I can see that some students joined later. So Akash, I want to hear from you. Okay, what do you think? How exactly or what kind of design came into your mind if when you thought about designing a symbol table? Katare Akash, you can unmute and speak. Akash, are you there? Okay, like if you don't speak, then I will assume that you are absent. Okay, Kanchan Kuwar. Yes, please. Kanchan, can you hear me? Okay, Amit Nale. Amit. Sahil.
Yes, sir.
Yeah. So what is your opinion? What thing came into your mind when you thought of designing your own data structure for symbol table?
Sir, I constructed a structure, one for entering keywords, which will be used as the symbols. Like it will have an basically I constructed using an array.
Array. Okay. Amol Kathare.
Yes, sir.
Yeah. What was your design? Chosen design.
I'm also going with RS, sir.
Sorry. Array only.
With
But
RS, sir.
but
Not
do
only
you
with.
think? Yeah. With array right now, na? So do you think it would be efficient one?
Yeah, sir.
Assume that number of symbols are 1000. Because it is not for a program that we are talking about. We have to give a generalized solution, which will be kind of efficient solution at some point of time. Correct?
Yes, sir.
Kanchan, you can unmute. I want you to speak. I'm only considering them to be present who are speaking in the class. Otherwise, I'm assuming you are absent. There's a robot sitting that side replying to my questions. Okay, by the way, I'm adding a test which you will be opting on Saturday. Okay, where you are supposed to answer the questions on laptop directly. Oh, sorry, on Moodle directly. I don't expect you to write on paper. It is to be written there only. Answer perspective. Your answer should be written on laptop. Sorry, on the space given there on Moodle platform. Is that fine?
Yes, sir.
Okay. So
Sir, it will be a theory-based paper, right?
yeah. Theory plus you. I may ask you to write about algorithm. Who asked this question?
Roshan.
Roshan. Okay. Yeah, it would be theory, but it may require you to write an algorithm too. Okay, algorithm in the sense some syntax of C probably or Python. Let us consider only these two languages to write the algorithm. Okay, so I already gave you 5 choices. Think of it. Try to choose the one which would be good in all parts. All parts, I mean to say, considering the complexity, implementation issues, and so on. So even if you are choosing array, I don't mind. But the problem is like why you are using it would be a question. Fine. OK, so be prepared for it. And I expect each one of you to speak in the class when asked. I don't expect you to type because you are not robots. I expect you to speak. Fine. So if your mic is not working properly, I don't care. You have to speak. And otherwise come in the department. You can sit in the department and answer my questions. Fine.